All right, lesson 4 in differentiation. Lesson 4 deals with the derivatives of trig functions. Trig functions becomes the big deal in the lesson. In the class period, we'll finish up our look at applications, but we really do want to hit trig functions, want to hit them hard. I want to do the first one from a purely theoretical standpoint. I want to do the other from a graphical standpoint, and then we'll see where it goes from there. So the first big theorem is that the derivative of sine x with respect to x is cosine x. That is the first big deal. So here we go. I want to prove this. So what does that mean? I'm going to take a limit as h approaches 0 of sine of x plus h minus sine x divided by h. If we throw in 0 for h, it doesn't fly. You get 0 over 0. So I've got to go all the way back to my Algebra 2 course with trig, where we learned how to do the sine of the sum of two angles. That is sine of the first, cosine of the second, plus cosine of the first, sine of the second. And you're saying, what formula is that? Well, you got to look that up and remember it, because trig is one of those things that keeps coming back to bite us. So I'd like to reorganize this if I can. I'd like to reorganize this into two fractions whose denominators are h. The fraction on the left is going to take the terms with a sine x in them. The fraction on the right is going to have cosine x and sine h. And some wonderful things are going to happen. First things first. It can be shown, and arguably was shown during our limits unit, that as h gets closer and closer to 0, that blue box gets closer and closer to 0. Completely obliterates the left term. The one that's much more familiar is the guy on the right, sine h over h as h approaches 0. What happens to that? Gets closer and closer to 1. And so I've got sine x times 0 plus cosine x times 1. That's cosine x. So the derivative of sine x is cosine x from the limit definition. Similarly, the derivative of cosine x, really, I can write with respect to x, is minus sine x. I'm going to take a look at this from a graphical standpoint. Oh, really? 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 There we go. There we go. We're in radian mode. We're going to graph cosine x like that. Let's do a zoom trig just for sport. And then I'll take a picture because it lasts longer. Love that sound. Brace. There it is. There it is. It's really loud in my ears. Okay. So we've got this thing. This thing is cosine x. So I look at the slopes of the tangent lines at a whole bunch of places. The slopes of the tangent lines here, 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 they're all 0. So the derivatives here, 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 they're all 0. It can be shown without too much trouble that the derivatives here and here are 1. Really? Really? 1. And similarly, the derivatives here and here are -1. And so what you get is this beautiful function that looks just like the sine function, but it's upside down. And so the derivative of the cosine function is the negative of the sine function. We can also run limit definitions. That's fine, but you want to make sure that you can see things both from an algebraic standpoint and a graphical standpoint. Marvelous. So the others all come for free. This is all stuff we now can do. If I want the other 4 trig functions, they all come for free now. I'm stalling for time. So, what's the guy at the top? That's the derivative of sine x over cosine x. The derivative of sine x over cosine x, it's the bottom times the derivative of the top minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom squared. Wait a second. That's cosine squared x plus sine squared x. What do we know about cosine squared x plus sine squared x? 1! That's 1 over cosine squared x. And some tree-hugging environmentalist is going to say, no, we can fit that in a smaller space, and we're going to get secant squared x. So that's the way people memorize it. They memorize tan x as the derivative of tan x as secant squared x. Awesome. So similar. Oh, I should change color. Let's go purple. Let's do it. Let's go purple. Yeah. Take that. So the same kind of thing happens here. And I will absolutely leave it to you to run the quotient rule and come up with negative cosecant squared there. The derivative of secant x, we're going orange. Yeah, take that. Yeah. That's the derivative of 1 over cosine x. It's the bottom times the derivative of the top. Goodbye! Minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom squared. It's calc. It's calc. We get that. So I'm going to rewrite this in the way it's going to appear in your textbook. This is sine x over cosine x times 1 over cosine x. You should pause to make sure that if a fraction has a denominator of cosine squared x, it can be expressed as the product of 2 fractions whose denominators are cosine x and cosine x. And that, without too much trouble, is tangent x secant x. And then maroon! I'll leave it up to you to prove that this is negative cotangent x cosecant x. That's a similar proof. You can run through the quotient rule yourself. So from your perspective, what do you have to know? You have to know that the derivatives of sine and cosine come from the definition. They can also be appreciated graphically. So I know what the derivative of sine x, I know what the derivative of cosine x is, I know what the derivatives of tan, cotan, secant, cosecant x are, because there is no formula book. You don't get a list of derivatives. You've got to know them, or you've got to be able to derive them. Either way will be fine. So real quick, before we're done, one example, because it's all about tan lines. We're going to find the equation of the tan line to y equals cosine x over x at pi over 2 comma 0, and that's going to close out our time. You're so close to freedom. I know how to find the equation of a tangent line. Anytime I see tangent line, it's y minus y1 equals x minus x1 multiplied by, shoot, what's the slope? Okay, we need a derivative. To do the derivative, it's the bottom times the derivative of the top minus the top times the, stop singing that. I know. So you do the bottom times derivative of top minus top times derivative of bottom over bottom squared, and we're going to evaluate that at pi over 2. And if we do that just right, we get pi over 2 times negative 1 minus 0 times 1 over pi over 2 squared, which happens to be negative 2 over pi. That's the kind of stuff you've got to be able to do very quickly. That's probably a 2-minute problem. I've gone to my time. You folks are amazing. Quick quiz tomorrow. You can do this.